Now this illustration deals with electrical system coordination in accordance with 240.12. But notice the definition can be found in Article 100 and should be reviewed if you're doing this and having to design or install this system. Now notice we have a ground fault at the equipment that's protected by the overcurrent protection device, and is number 4. Now when that fault develops there, we should trip that overcurrent protection device marked 4, not the one upstream that is marked overcurrent protection device number 1. Now to have selective coordination is a rule of thumb now. Remember, this is a rule of thumb. A circuit breaker is usually required to be 3.5 times larger. Now, for example, if I had, say, a 350 amp main overcurrent protection device 1, the downstream should be 100 amp or less. And many times I'd have selective coordination without going through a lot of calculations. But this is a rule of thumb, and some breakers that wouldn't work on, sometimes like Federal breakers, Bulldog breakers, Ozenco breakers. So a little common sense should be used here. Now, sometimes a fuse, if it's a time delay, downstream's 2 times. If it is a non-time delay fuse, it would be 2.5 times. If it's a time delay, it'd be 2 times. So anything downstream then would be based upon that value. Now, that's a rule of thumb, or you could calculate it, and we have the method of doing this. And the Volume 2 Stallcup's Electrical Design Book shows the procedure for performing these calculations to be exact. Now, this figure 9-19 is illustrating we should localize the fault where if we tripped a main, it would knock the whole system out, the whole feeder, and that's what this illustration is showing in accordance with 240.12.